Good day, everybody. How are you all doing? Hope you are doing great today. Um, those of you who do not know me, this is Dr. Nandi. Today we are going to discuss about the confidence interval for the population mean when the population standard deviation is known. If I would tell you in the beginning that the population uh, the confidence interval for the population mean when the standard deviation population standard deviation is not known is wider than the confidence interval for the population mean when the population standard deviation is known. So first I will work out with Excel how to calculate the confidence interval for a population mean when the population standard deviation is not known. Then I will show to you that that the confidence interval for the population mean is greater when the is greater when the population standard deviation is not known as compared to the fact when the population standard deviation is known. Let's take a quick look at it. So I'll share my screen with you. We will be using Excel instead of using the calculator. So here I go. Nope, this is not it. Stop sharing. Share. This is it. A simple random sample of 25 hybrid SUV SUVs show a mean of 48 miles per gallon with a standard deviation of 10.7 miles per gallon. Calculate the 90% confidence interval for the population mean miles per gallon. Part B, can the manufacturers claim that the hybrid SUV will yield more than the 15 miles per gallon be rejected? We will work out those part A and part B. Then I will assume in the first two cases, I will assume population standard deviation is not known. The population standard deviation is not known. The sample standard deviation is 10.7 miles per gallon. As you realize, standard deviation is a measure of average variation or deviation from the mean. And this is a sample data of 10.7 miles per gallon. The sample mean is 48.4. Sample size is 25. And I'm going to calculate the 90% confidence interval. What does it mean? That if I repeat this experiment 100 times with 100 sample data, and construct 100 intervals with this method that I'm going to use right now, 90 of those intervals will contain the actual population mean. So the confidence level is the effectiveness of the method that I will use. Point to be noted, here the sample mean and the sample standard deviation is known. Okay. Population standard deviation is not known. In that case, we cannot use the z distribution, the standard normal distribution. We cannot use, and we cannot construct the confidence interval using the standard normal distribution. So we will use the t distribution. So how to use it? So I'm going to use Excel for part A. So let's use Excel. So since the population standard deviation is not known, use a t distribution instead of z distribution. So I write equal to confidence. Equal to, for any formula in Excel, you have to bring in the equal to sign. Confidence is CON. Now notice there are two confidence. One is confidence.norm, that is for the z distribution when the population standard deviation is known. The second one is confidence interval when the population standard deviation is not known. So I'm going to use confidence.t. Remember that. And I will write it down also. Confidence.t. Alpha. What is alpha? If you have watched my previous video, I have mentioned that alpha is the complement or opposite of the confidence level. So in this problem, the confidence level is 90%. Everything adds up to 100%. So the opposite of 90% confidence is 10% level of significance. Significance. which is alpha. So alpha is 1 minus zero point 0.9, zero point 0.9 for 90% confidence interval. So alpha, which is also called level of significance, this is the maximum risk we are taking in making a wrong decision or making a wrong calculation. E is equal to, in this case, 1 minus zero point 0.9. So I will type zero point 0.1 decimal 1, okay, comma, standard deviation. My standard deviation is given as 10.7, okay, comma, it needs the sample size, which is 25, okay, and you close it with the right parenthesis. And this is the, what is this? This is called the margin of error. Margin of error. This is not the confidence interval. This is the margin of error. Okay. So the formula for this I will write here. Confidence dot T in parenthesis your alpha, which is opposite or complement of level of confidence, comma, standard deviation, comma, size, sample size. That is the formula that I used. Okay. And this is the margin of error. Question is, what is margin of error? Margin of error is the sample mean minus margin of error. Let's first write it down. Margin of error is also indicated by the capital letter E. It is the sample mean minus the population mean. Minus population mean. Okay. So the confidence interval is given by X sample mean minus the margin of error minus E, comma, sample mean plus E. So the two boundaries, the lower boundary of the confidence interval is sample mean minus E is the margin of error, which we got from the TIA from Excel. And the upper end or upper boundary of the confidence interval is sample mean plus E. So what is my confidence interval then in this case? I know my sample mean. Let's do the lower boundary. Lower boundary and equal to the sample mean is given as 48.4. 48.4 minus the margin of error which we calculated in cell A5. Okay. That is the lower boundary. Okay. So let's okay. That's the lower boundary. What is the upper boundary? It is the sample mean. So let me write down, no, it is already written. Upper boundary and lower boundary. So lower boundary. Okay. And upper boundary is X bar sample mean plus E. So equal to sample mean is 48.4, 48.4 plus the margin of error, which is in cell A5. Plus A5. Notice A5 is highlighted. So it is for 52.06. So basically we can write the confidence interval. This is written in this form: 44.74, comma 52.06. So with 90% confidence, we can state that the actual population mean will be between these two numbers. So that is our 90% confidence interval. And this is the, we can write 90% confidence interval for the mean, for the mean. Now to work out the part B, okay, part B. So let's part B here. Let me copy this over here. Control C, Control, let's do it over here, Control B. Okay. Since the 90% confidence interval contain 50 miles per gallon, because 50 miles is inside that confidence interval, 50 mpg, the manufacturer's claim cannot be rejected. Cannot be rejected. Okay, so that is the answer to part B. 50 is inside the 90% confidence interval. So the manufacturer's claim of 50 miles per gallon cannot be rejected. Now I was going to show you that the Z interval is shorter in width than the T interval. Let's do the calculation for Z. Assume extra. Assume the population standard deviation is 10.7 mpg. Instead of using that as a sample standard deviation, we'll use that as a population standard deviation. Now the calculation will be confidence dot norm, norm, and inside the parenthesis will be alpha standard deviation, then standard deviation, then size, comma, everything is separated by comma, size. So the margin of error, so equal to, let's do the calculation, equal to confidence, CON, confidence dot norm, my alpha is 0.1 because it's a complement of 0.9, 1 minus 0.9, 0.1, 0.1, comma, my standard deviation is comma 10.4, right? Yep, 10.4, I mean, sorry, 10.7, and sample size is still 25. This will give me the margin of error. Okay, what happened? Okay. So no, 1, comma, standard deviation is 10.7, right? It's 10.7. Oops, 10.7, 0.7, comma, and sample size is 25, light parenthesis. So this is your margin of error now. Compare that margin of error with the T interval. With the T interval, assuming that the sample standard deviation, the margin of error is wider than the case of uh, margin of error for Z interval. margin of error. So like I said in the beginning for Z interval, that the confidence interval for uh, T interval is wider, okay, because we do not know the population standard deviation. We are working with the sample standard deviation. So there's some doubt in the actual population standard deviation without it being known. Hence, for the T interval, the confidence interval is wider, as you will see. So I'll calculate those numbers, the lower and the upper. So equal to sample mean is 48.4, I believe. Let me make sure. Yes, equal to 48.4 minus what is in cell A16 minus A16. A16 is the lower boundary and the upper boundary is 48.4 plus A16, sorry, is the upper boundary. So now look at the confidence interval is 44.88. Mm, 88, comma 51.91. And you can see the already the upper level is lower than so width in this case is width of the interval equal to 51.91 minus 44.88 minus 44.88 equal to what is it 0.356 6.03. Mhm. And here the width of the interval is equal to 52.06 minus 44.74 equal to minus 44.74. 44.74 equal to 7.36. 7.423. Yeah, 7.32. Here the width is 6.03 with the T interval, width is higher. Width is the upper minus the lower. So it is much wider in case of T interval. The reason is population standard deviation is not known. For Z interval, assuming population standard deviation is known, the interval is shorter because we are sure about the spread in the miles per gallon, population spread in miles per gallon from the mean. In part A, we are not sure, so we're using the T interval equal to confidence dot T, and that gives you the margin of error. Now, to get that lower end and the upper end, you subtract the mean miles per gallon minus the margin of error. Mean miles per gallon plus the margin of error gives you the upper boundary. These are the ways. So Excel basically gives you the margin of error. And you get the two ends of the interval by subtracting at the lower end and adding the margin of error at the upper end. I'll stop here today. I'm sure you may have some questions. Hey, no problem. Shoot me a question in the comments area. I'll get back to you as soon as possible. If you like this video, please give me thumbs up. I appreciate that. And please subscribe to my channel by hitting the red subscribe button. And please do not forget to check me out tomorrow when I'll be back with another new video. Take care. Have a nice day. See you. Bye.